Okay, so we are now starting consumer choice theory. We'll be looking at the behavior of a consumer. We'll be looking at utility. We'll be looking at marginal utility. We'll be looking at diminishing marginal utility. Yeah, those things. We'll be looking at indifference curves. Yeah, we'll be looking at utility maximization. Those things, right? Yeah, so basically we have about 4, if not 3, economic agents. We have consumers, we have producers, we have the government, we have the financial sector, and then we have the external sector. But for this particular course, managerial economics, the attention really is given to consumers and producers, because you as a manager are supposed to understand the behavior of a consumer, because obviously you are producing that output for that particular company, so that at the end of the day the consumer must benefit. So therefore it is important for you as a manager to understand how consumers behave. So that is the reason why we are doing this particular topic, okay, because this is managerial economics, and we as managers must understand the behavior of consumers, right? Yeah, so we'll look at basically these, okay. So do the intro, we'll do the description of consumer preferences. We're going to look at what we call utility functions. Under utility functions, we're going to do marginal utility and diminishing marginal utility. Thereafter, we're going to look at interface curves, then marginal rate of substitution, then at the end we're going to look at the special cases. We have special functional forms. Yeah, so this is the structure of this particular topic. So we did demand and supply. We looked at demand and supply, and we also understood how or what demand is, and also what quantity demand is. We looked at supply and what quantity supply is. Yeah, we also looked at the determinants of demand, those things, and also the determinants of supply. So we remember what we said. We said that there is individual demand, then there is market demand. So with individual demand, we're just looking at what Matab was demanding, but the moment we aggregate what Zambians demand, we have what we call market demand, right? Yeah, so we've got market demand, and then that gives us the market demand curve, right? Yeah. So now we want to understand how individuals make those decisions about what to buy. Why should they buy it? What are the underlying factors behind the decision to purchase. So basically that is the aim of this particular topic. Okay, so yeah, so we need to more like come up with something that is going to help us understand consumer behavior. All right, and this thing I'm going to call it a model. A model in economics is just something we use to simplify reality. Okay, that's a model. So a model is anything that we can use to simplify reality. Okay, so in this case we should come up with a model that is going to explain how consumers behave, right? And this particular model must depend on, or must be based on, what we call individual tastes, okay, or preferences, okay, because these individual tastes and preferences determine the amount of satisfaction that people derive from goods and services. So it is these tastes and preferences that determine the utility that I'm going to derive from the consumption of any good or any service, right? Yeah, so our model is going to depend on consumer tastes and preferences. Then this model should also depend on the budget constraint, because the issue is, yes, I might want to have an iPhone 14, but I don't have that money, okay, which means that my utility is constrained by the budget that I have. I don't have that enough money for me to purchase that particular good. Therefore my my utility or my satisfaction from the consumption of that particular good is going to be constrained by my budget, right? My budget is going to more like put a barrier, put a limit. Okay. Again, the last thing that is going to help us build this model is consumer utility maximization. So the assumption is that consumers want to maximize the utility that they derive from the consumption of various goods, but of course this maximization of utility is constrained by the budget that they face. Okay, we don't have enough money to buy, let's say, a Benz that we want. We don't have enough money to buy that nice Jeep that we want, but of course we want to maximize our utility, because the moment we get that Jeep, we're going to maximize our utility, right? But we're constrained by the budget. So this is the problem that every consumer faces, and this problem is that of budget. We are constrained by the resources that we have. We are constrained by the financial resources that we have. We don't have enough to maximize our utility. Therefore, we want to try by all means to come up with a model that is going to help us predict the behavior of consumers, right? We want to try by all means to come up with that is going to help us come up with a model that is going to help us maximize, that is going to help us understand how consumers behave. Okay, so this is the skeleton that we're trying to build. Okay, so the most important factor, okay, the most important factor about consumers is the preferences. Okay, because consumers make decisions based on their preferences, right? Even right now, someone somewhere has made a decision because of what they prefer. Okay, so consumer behavior hinges on their preferences. Why? Because this thing called consumer preferences helps us understand how consumers would rank, various or let's say two goods. Using preferences, a consumer is able to rank these two baskets of goods to say, I love this, or I prefer this to that. Okay, this comes at number one, this comes at number two, because of their preferences. Okay, so consumer preferences are more like the benchmark, the baseline for or that is used when we are trying to understand the behavior of a consumer. All right, so now these baskets or bundles, we call them bundles, is just more like a collection of all those goods and services that an individual might end up consuming. So for instance, when we say a basket, or in economics, when we say basket, we don't necessarily mean that particular basket. We mean a basket of goods and services. We mean a combination, a collection of goods and services. So consumers make their decisions based on their preferences, right? Yeah, and therefore this is what helps them to choose these various bundles. Okay, so everything hinges on consumer preferences. Okay, now we need to understand the assumptions of consumer behavior. What are the underpinning assumptions of consumer behavior? What determines consumer behavior? So the first assumption is that of completeness. So if you did microeconomics, this is not new. Yeah, so if you did microeconomics, this is not new. This is also in microeconomics, but it's applied in managerial economics. Okay, so the first assumption is that of completeness. So when you say preferences are complete, it means that given, let's say, two choices, okay, choice A and choice B, a consumer is going to tell us to say, well, I prefer A to B, or I prefer B to A, or I love both A and B. In short, when we say that preferences are complete, we mean that this consumer is going to tell us, given two choices, A and B, this consumer is going to tell us to say, I love this to that, I love this and that, or I prefer this to that. Okay, so given two choices, let's say given two bundles, bundle A and bundle B, and we've defined a bundle to say a bundle is just a collection of various goods and services, a basket containing various goods and services, right? So given a bundle, or given two bundles, bundle A and bundle B, okay, given two choices, choice A and choice B, we say that preferences are complete if this consumer is able to tell us to say, I strictly prefer B to A, okay, or maybe I strictly prefer A to B, or given a situation where this guy loves both A and B, we say that this consumer is indifferent. Okay, he's indifferent between bundle A and bundle B, meaning that he loves both A and B. Okay, so that is what we mean when we say preferences are complete. So preferences are complete if and only if a consumer is able to give us the exact bundle that is preferred, or if this particular consumer is in a dilemma where he cannot choose between these two, which means that he or she is indifferent. Okay, which means that this particular consumer is indifferent. So when we say you're indifferent, it means that you cannot really go either to the right or left. Okay, yeah, you can't choose between these two bundles. Okay, you cannot choose between these two bundles. So every time we're talking about completeness of preferences, we refer to this. Okay, it's either bundle A is strictly preferred to bundle B, or maybe bundle B is strictly preferred to bundle A, or maybe you are in that dilemma where you can't choose between bundle A and bundle B, which means that you are indifferent. You are indifferent. Okay, which means you are indifferent. Okay, I believe this is all good so far, except for Mr. Sinkara, who has joined a bit late. That's okay, right? Someone to confirm?
Yes, sir.
No, okay, perfect. Now, the second assumption of consumer behavior is that of transitivity. Okay, transitivity, or sometimes it's called that of transitive anyway, but it's supposed to be transitivity. So with transitivity, we say that preferences are transitive, which transitive. Okay, let me just admit someone. Yeah. So with transitivity, basically we're just saying that, okay, if a consumer is given two choices, right, or three choices, A, B, and C, okay, then if this guy is going to say that I prefer bundle A to bundle B, okay, and then he says I prefer bundle B to bundle C, then it must be automatic that he also prefers A to bundle C. Okay, let me just illustrate that. Yeah, so with transitivity, given three choices, right, bundle A, bundle B, and bundle C, if this guy is going to say I prefer A, okay, I prefer A to B, and then I also prefer bundle B to bundle C, okay, it must be automatic that since A is preferred to B, B is preferred to C, then since this bundle A is better according to this guy, is far much better compared to bundle B, and since B is better compared to bundle C, then A, okay, must be preferred to bundle C. Okay, so in short, preferences are transitive. So it's transitivity. We just say that, well, we just mean that if given three choices, right, bundle A, bundle B, and bundle C, if this guy reports that he prefers bundle A to bundle B, and also bundle B to bundle C, then it must be automatic. It must be transitive. It must be automatic that he also prefers bundle A to bundle C. So this is what we mean when we say preferences are transitive. In short, if you report that I like this compared to that one, I also like that one to that one, then it's automatic that this thing that you have reported first should be like the optimal, okay, or should be the best among all of them. So if A is preferred to bundle B and B is preferred to bundle C, then it must be automatic that A is preferred to bundle C. So that means that these preferences are transitive. So that is the assumption of transitivity. That is the assumption of transitivity. Okay, how is that? Is that okay? Should I repeat? How is that?
No, this one is clear, sir.
Oh, okay, perfect. I'm glad to hear that. Okay, let me just delete this empty slide. Okay, then the most obvious one is the more is better, or monotonic assumption. Okay, so with monotonic assumption, we just assume that a consumer loves more of a good. Okay, you love more of a good, I love more of a good. That is the assumption of more is better, or the monotonic preferences. Okay. All right. So with monotonic preferences, we just assume that anyway, the assumption is that consumers just love more of, you just want more of a good. Okay, just want more of a good. In short, more is better. Okay, more is better. And the other term we use is that of non-satiation. Okay, so we also use this term here, non-satiation, which means that consumers want to be, want more and more and more and more of a good. Okay, you want more of a sweet, you want more of sugar, you want more of money, you want more of everything. So as a consumer, that is the nature of consumers. Remember, we are trying to understand the behavior of consumers. We want to understand how consumers behave. Okay, so monotonic assumption is the assumption that more is better. So consumers prefer more and more and more of anything, as long as that particular thing is good. Okay, so the assumption is that people want more of a good, and there's a difference between a good, between a good and a bad. Okay, so when talking about a good, this is anything that consumers want more of it than less of it, right? And a bad is anything that consumers want less than more of it. An example of an economic bad is pollution. Okay, we don't want pollution, so that is an economic bad, but we want money because money is a good. Okay, we want sugar because sugar is a good. We want more of this. So a good is anything that consumers want to have more than less of it, and the bad is anything that consumers want to have less than more of it. So the monotonic, when we say preferences are monotonic, we mean that preferences follow this assumption that more is preferred to less. Okay, I believe that's okay as well. So let's try to apply this using this graph here, assuming that on the y-axis we have units of clothing, and then on the x-axis we have units of food. So the question is, which bundles are better because more is better? So any rational consumer cannot go for bundle D, given that there are all these other bundles here. Why would you want to have 10 units of clothes and 20 units of food when you can have 30 units of clothes and 6 units of food? Okay, why would you want to have 20 units of clothes and 40 units of food when you can have actually 30 and 60 of these goods? Okay, at the same time, why would you want to have only 30 units of clothes and 0 units of food? Are you going to be eating clothes? Okay, at the same time, why would you want to have only food, 6 units of food and nothing of clothes? Are you going to be putting on your food? So in short, the best bundle is this one here, bundle A. Okay, so as we progress, we are going to understand that the far you are from the origin, the better. Okay, or let me just explain that now. So here, the logic we use to select the best bundle is this assumption that the far you are away from the origin, the better. Okay, so bundle D is too close to the origin compared to bundle A. Therefore, bundle D is not an optimal bundle. Bundle G, same thing. You can improve from G to A. Therefore, why should you be at G when you can at A, where you have 30 units of clothes and 6 units of food? In short, more is preferred to less. You prefer to have more of this good than less of it. Why? Because that is the nature of a consumer. Okay, how is this? It's okay, right? Can we forge ahead? Can you forge ahead?
Yes, this is okay.
Okay.
No, I'm a bit behind. Just
Okay.
explain.
Carry on. What's the question? Where should I clarify?
There on that graph, I was just distracted a bit. I didn't hear what you explained.
Okay. All right. So, what I think is that the question is which bundles are better because more is better, or in short, using the assumption that more is better, let us decide which bundle is better, since more is better. All right. So when you look at, let's start with bundle D. When you look at bundle D, there we have 10 units of clothes and 20 units of food. When you look at bundle G, there we have 20 units of clothes and 40 units of food. When we look at bundle A, there we have 30 and 60. Okay, so since more is better, it makes more economic sense. Okay, it carries more economic sense to be consuming bundle A than G, D, H, E, or B. Okay, why? Because, for instance, let's take bundle H for instance. At bundle H, you only have 30 units of clothes, but more is preferred to having less. Why should you only have clothes when you can move to bundle A, where you're going to have the 30 units of clothes and the 6 units of food? Okay, same applies to bundle E. There you only have 20 units of food and 30 units of clothes, but you have room to move to bundle A, where you're going to have 30 and 60. So in short, the best bundle is bundle A. Why? Because more is preferred to less. We love more than less. We want to have more than less of any good. Alright? That's okay, madam? Okay, I didn't really get that the response, but I assume you said yes.
I said it's fine now, I get it. Thank you.
Okay, perfect. Now, we have just been talking about the consumer behavior from the theoretical point of view. Now, let us bring in the mathematical part. Okay? But of course, the math is not that complicated. So, we are safe to look at what we call a utility function. Okay? So a utility function is just any function that tries to measure the level of satisfaction that a consumer is going to derive from the consumption of a particular basket of goods. Okay? So a utility function is just a function that tries to explain that tries to show the level of utility, and in this case utility, by utility we mean satisfaction. Okay, so a utility function is just a function that tries to link, or that tries to show, or that tries to measure, okay, the level of utility that consumers derive from the consumption of any given basket of goods. So utility therefore is nothing but a function of the various goods that we are going to consume, okay, up to xn. So this is our utility function. So our utility function is a function of these various goods that that we're going to consume. Okay, so utility function is a function of x1, x2, x3 up to xn. So the x's are just the various different types of goods that we're going to consume. So practically we can say our utility function is, let's say, a function of, let's say, sugar, okay, let's say salt, let's say Fanta, all the various goods and services that we're going to consume until the last one, xn. So this is what we call a utility function. So it just shows that the utility that, or the satisfaction that I'm going to have is going to come from the consumption of these goods here. Alright, so that is what we call a utility function. Okay, that is what we call a utility function. But there's something fun about utility. Okay, there's something fun about utility, and that is that utility cannot be compared to, let's say, across individuals. The level of satisfaction that I derive, the level of satisfaction that I'm going to get from using, let's say, a Samsung phone is different from the level of satisfaction that someone can derive from using the same phone. Okay, the level of utility that I'm going to derive from the use of, or from the consumption of, let's say, Anshima is different from the level of satisfaction that someone else is going to derive from the consumption of the very Shima with the same relish, with the same cook on the same plate. So in short, utility cannot be compared across individuals. Okay, alright, so that's the most important thing. That's the most important thing. The other thing is that utility can be ranked to say I derive this much from this good, I derive this much from this good, I derive this much from this good, and that is what we call the cardinal approach. Okay, the cardinal approach to utility measurement. Let's discuss this. So using the cardinal approach, we are saying that what am I saying? Using the ordinal, not the cardinal. Okay, using the ordinal. So there are two approaches. There is the ordinal, and then there is the cardinal. So using the ordinal approach, okay, using the ordinal approach to measurement of utility, we assume that we can rank, utility. That okay, I derive much utility from this bundle, I derive much utility from this bundle, I derive much utility from this bundle. But of course, the key with ordinal approach is that we don't assign actual figures. We cannot properly say that I derive 20 utils. So the measurement for utility are called utils. Okay, utils. So using the ordinal approach, we cannot specifically confirm or specifically measure and report that I derive, let's say, 20 utils from the consumption of sugar, I derive 10 utils from the consumption of salt. You cannot really come up with those figures, but the only thing you can do is to rank them according to the levels of utility. On your own, you can tell that I think I get much satisfaction from the usage of an iPhone compared to Samsung. Okay, so therefore you can just rank them, minus necessarily putting numerical measurements. Okay, that is with the ordinal approach. But the opposite is true for the cardinal approach. With the cardinal approach, we can put actual figures now to say, okay, if I use an iPhone, I'm going to derive 20 utils. If I use an Android phone, let's say Samsung, I'm going to derive 15 utils. Therefore, I derive much utility from an iPhone. So those are the two approaches that we use to measure utility. We can either use the ordinal, where we just rank, okay, depending on our satisfaction, okay, or we can use the cardinal, where we can actually assign specific numerical measurements, okay, to say, okay, if I consume this good, I derive 20 utils. If I consume this good, I derive 100 utils. If I consume this good, I derive this much utils. Okay, so we've talked about a utility function, that this is just a function that shows or that measures the level of satisfaction that a consumer is going to derive from the consumption of a given bundle, right? And then we have also said that with utility, we can measure utility using two approaches. We can either use the ordinal, where we just rank minus assigning actual numerical measurements, or we can use the cardinal, where we can actually assign specific numerical measurements. All right, how is that? Is that okay? Is that okay, Mr. Sinkala? That's fine.
Yeah, it is very straightforward, sir, for me.
Okay. All right, that's good to hear. That's good. So I'm rushing against my phone. Apparently, I've lost my cable. I don't know how. So, and I'm using the phone to hotspot, and it's now at 6%. So I'm really trying hard to cover as much as I can before the phone can actually black out. Okay. Oh yeah. Okay. Oh yeah. So there's the we've talked about utility functions, right? It's like that and that and that. Okay, now let's start dealing with graphs. Okay, so one thing about consumer theory is that there are a lot of graphs and also to some extent some calculations, but it's okay, we can handle this. Okay, so So let us assume that, or in short, now we want to look at what we call total utility. Okay, I want to look at what we call total utility. So total utility is just the summation of the various utilities we get. So utility 1 plus utility 2, just like that. That is what we call total utility. So total utility is just the total satisfaction that we are going to derive from the consumption of various goods. Okay, so here is a situation where we have got the weekly consumptions of muffins, and then we are trying to measure the total utility that we are going to derive from the consumption of these, right? So when you consume 1 unit, okay, when you consume 1 unit, you are getting 1 UTO, or in case you are getting 1 level of satisfaction. When you consume 2 units, you are getting 1.5 levels of satisfaction. When you consume 3 units, you are getting 1.75 levels of utility. So now this locus, okay, this locus here is what we call the total utility function. Okay, so it's just giving us the total level, or the total level of utility that we derive from the consumption of these goods. So when you consume 1, you have got that level of utility. When you consume 2 units, you've got that level of utility. When you consume 3 units, you've got that level of utility. So this function now, this function is what we call the utility function. Okay, is what we call the utility function. But again, one thing that we're supposed to take note here is that, look, when you're consuming 1 unit, you have got 1 level of satisfaction. When you increase the consumption from 1 to 2 units, your level of consumption has increased, but by 0.5. And this 0.5 is what we call the marginal utility, the incremental utility. So marginal utility is just a change in total utility due to change in the consumption of this particular good. Okay, so marginal utility is the increase in total utility as a result of the increase in the level of consumption. So as you increase consumption by 1 unit, how does that affect your total utility? So you call that marginal utility. So marginal utility is just a change in total utility as a result of 1 unit change in the consumption of whatever that good may be. Okay, so in this case we've talked about 2 concepts: the concept of total utility and the concept of marginal utility. With total utility, we're just measuring the summation. Okay, we're just summing up the various levels of satisfaction you're deriving. Okay, so 1 unit you have got 1, 2 units you have got 1.5, 3 units you have got 1.75. So that is just total utility. Okay, but with marginal utility, we try to ask ourselves to say, okay, if I move from this point to that point, how is my utility changing? Okay, so on a marginal basis, how is my utility changing? So that is what we call marginal utility. So marginal utility measures the change in total utility as a result of a 1 unit change in the consumption of this particular commodity. Okay, all right, is that okay? Is that okay? Can someone confirm?
Yeah, it's clear.
Oh, perfect. So now mathematically, so we're saying that the marginal utility is a rate at which total utility changes as the level of consumption rises, right? Which is the same thing just from explaining that the change in total utility per change in x, where x is the good. So this is what we call marginal utility. So now I mean, it's just what I'm from explaining, right? that the marginal utility of consuming an extra unit of good Y is equal to change in total utility per change in Y, which is just a derivative of the utility function with respect to Y. Okay, now let me just say something here, that we can have a function. Remember, this is mathematics, right? So you can have a function of utility. Let's say it's a function of good x1, which is let's say 4x1 squared, let's say plus 3x, assuming that this is our utility function. Then the question could be, find the marginal utility, given that this is a utility function. Let us find the marginal utility. So we know that marginal utility is just equal to change in total utility per change in good x, right? Which is just differentiating this particular function with respect to good x. Okay, with respect to good x. So we know that when you differentiate this, we are going to have 8x. What is this now? Sorry about that. So we know that this is just going to be 8x, okay, plus 3. Okay, so I'm sure by now we know how to differentiate, right? Yeah, I assume we know how to differentiate. So that is going to become our marginal utility. That is why I say that let us first do differentiation, because I know that differentiation is applied everywhere. Okay, yeah, so that is going to become our marginal utility. So this function now is trying to measure how total utility changes as we consume an extra unit of this particular good. How is that going to affect our total utility? So we call that marginal utility. So marginal utility just measures the change in total utility per unit change in the consumption of this particular commodity under consideration. Okay, so that is basically what marginal utility is all about. Now I've just remembered something just about now. There are times when they're going to ask us to say, 1, find the marginal utility, 2, find the utility maximization quantity. In short, find the actual amount that this particular consumer should consume for his utility to be maximized. Okay, there are times when they may ask us at particular question to say, find the actual units that this particular consumer must consume for his utility to be maximized. So how do we do that? So the first thing is to get the marginal utility function. After getting the marginal utility function, you equate it to 0, and then you solve for x. Okay, so assuming that this is true, this is our utility function, and then we have the marginal utility function to solve for the utility maximization units, given that you are only consuming one good. Of course, given that you're only consuming one good, in this case is good x, you just get the marginal utility function, you equate it to 0, then you solve for x. So in this case, this would have been 8x. Okay, 8x is equal to -3, right? And then you divide both sides by 8, then you cancel there, you have your x is equal to -3 over 8. But of course you cannot have a negative quantity. Okay, so it's because of the way I've structured the question. If this question was having a negative here instead of a plus, everything would have been better. Okay, which means that the quantity should be positive. So in short, there are times when they may end up asking us to get what we call the utility maximization quantity. So if you only have one commodity, differentiate that particular function, equate it to 0, solve for that particular quantity. Okay, so we've looked at we've talked about total utility, we've talked at margin, we've also talked about the marginal utility, and we have also talked about the utility maximization quantity, right? Utility maximization quantity, that if you only have one commodity, okay, you just get the marginal utility function, you equate that to 0, then you solve for x. Okay, you solve for q, depending on how the function has been structured. Sometimes they can give us x, but in most cases, since this is economics, they will instead use q instead of x. So don't get confused, it's just one and the same thing. The logic, steps, everything same. Okay, I believe that's fine, right? I believe that's fine. Feedback? That's okay, right?
So far so good.
Oh, perfect. All right. So here we just perfect. Now there are times when we don't have one good. Okay, we have two goods, good x and good y. Okay, so the logic is the same. For us to find a marginal utility of each good, we just differentiate the utility function. Okay, so if we have, this is now an exam hint, if we have two, okay, let's say x and y, okay, so we are saying that the utility function is a function of two goods, good x and y, and let's say this is defined to be 4x squared, let's say minus what, minus anything, let's say 3, okay, let's say minus 3y to the power 3. Given that this is a utility function, how do we get the marginal utilities? Okay, so since we have got two goods, since we have got, can you get me? Can you get me? Someone was calling, so I suppose my internet has been disturbed. Can you get me?
We can get you now, but we stopped getting you at some point.
Yeah, sorry. Someone was calling. Yeah, and I'm using the phone to hotspot. This person, really?
You can just repeat on that exam hint that you started.
Okay. Let me just do that. Alright, so I was saying that there are times when we have two commodities. Let's say x and y. Okay? And let's assume that this was something like 3x squared, let's say minus 2y to the power 3, for instance. Given that this was our utility function, to get the marginal utility of good x and of good y, we just we use what we call now partial derivatives. Because I've got two goods, good x and good y, we use what we call partial derivatives. And with partial derivatives, we are going to differentiate. So for instance, if we are trying to get the marginal utility with respect to good x, we are going to partially differentiate the utility function with respect to x. In short, we are going to get we are just going to differentiate those parts containing x. So for instance, if we're getting the marginal utility with respect to good x, we're just going to differentiate this part. Why? Because this is where x is. When getting marginal utility with respect to good y, we're just going to differentiate this part. Why? Because this is the only part where y is contained. Okay, meaning that, for instance, marginal utility with respect to good x is just going to be 2 times 3, giving us a 6x, okay, as the marginal utility with respect to good x. Okay, again, if we are trying to get the marginal utility with respect to good y, it would have been just this part, which would have been 2 by 3, 6y to the power 2 as the marginal utility with respect to good y. So these are just hints, exam hints, because in an exam they try to to complicate our lives, but these are the hints that we're supposed to know. Okay, in short, it doesn't really matter, the nature of the function doesn't really matter. They can give us anything. They can give us a polynomial, they can give us let's say a simple quadratic equation. It doesn't really matter, as long as we know how to differentiate. It doesn't really matter. The key is knowing how to differentiate. Now, before my phone can actually black out, it's now at 3%. Samsung phones don't have strong batteries. If it was a Techno phone, for Infinix, it can reach even tomorrow. Okay, so there is one thing that is very important or worth discussing, and that is the concept of diminishing marginal utility. The concept of diminishing marginal utility. So with the concept of diminishing marginal utility, we're just saying that, well, the increase in utility as we increase consumption, this increase in utility keeps on decreasing. Okay, let's say you're eating shima. The first lamp is going to be sweeter, nicer, because you're hungry. The second lamp, the third lamp, the fourth lamp, you even stop eating. So in short, the level of utility, the increase in utility keeps on reducing as you increase the consumption of this particular commodity. And that is the concept of diminishing marginal utility. Utility keeps on diminishing as you keep on increasing the consumption of this particular commodity. Alright? So that is diminishing marginal utility. The level of the increase in consumption should be, the increase in satisfaction decreases as you increase the consumption, meaning that there's more like a negative relationship between the increase in total utility and the increase in consumption. As the increase in consumption increases, the increase in satisfaction keeps on decreasing. The first lamp, you're going to hammer with that much satisfaction. The second lamp, even if you are hammering with shima with let's say chicken, the point is that the second lamp is going to be less satisfying. The third lamp, less satisfying. The fourth lamp, 60th, we should stop eating. Alright, so that is the concept of diminishing marginal utility. I believe this is okay, right? I believe this is fine. That's okay, right? That's okay, right? Okay, I didn't get the response.
Yeah, that's okay on my end. I don't know about others.
Mr. Sinkala, that's okay?
Yes, but have you recorded? Because I missed the first part. I joined a bit late.
Yes, everything has been recorded.
If your phone becomes like it goes off, have you saved? I'm very concerned about the recording.
So the recording is done on the PC. The phone is just supplying network. So even if the phone blacks out, the recording will still be there.
Okay. Thank you, sir.
You're welcome, sir. You're welcome. So, for the sake of my phone, I'm kindly asking if we could end now, because it's at 3%, so we can just cut anytime, so to avoid those complications. I don't know how I've just misplaced my charger. I've tried to search everywhere, I can't find it. So let's pick it up from here tomorrow. Yeah, let's pick it up from here tomorrow, because I really want us to cruise, because time is ticking. I'm sorry about the whole thing. I'm sorry. I'm sure by tomorrow I should replace the charger. That's okay, right?